Today we are asking our intralogistics expert Matthias Göhner questions about improving efficiency in intralogistics. Hello, Mr. Göhner. Thank you for your time. In today's intralogistics, processes are becoming faster and more efficient. But what role does Lloyd's sensor technology play in this?
To make processes in intralogistics faster and more efficient, various factors must be optimized. This often involves quickly detecting or measuring in fast-moving processes. This requires sensors that can collect data even faster and more accurately than was the case several years ago. For example, the operating speed of a stacker crane or a shuttle has significantly increased. Containers or boxes are also transported much faster on conveyors than before.
What are the specific cases?
For example, today, at speeds of up to 3 meters per second, it is necessary to safely measure the position of a stacker crane and provide the data without significant delays. In the area of shuttle positioning, a sensor must reliably detect punched position holes at speeds of over 4 meters per second.
What significance do concepts like same-day or one-hour delivery have for intralogistics in the context of micro-fulfillment centers?
These concepts introduce a new additional type of warehouse logistics. To be able to deliver to a customer within an hour, it is necessary for the distribution centre where the goods are located to be closer to the customer. Otherwise, the delivery route is too far, and delivering the goods to the customer takes too long. Smaller, local distribution centres are required for this purpose. These so-called micro-fulfillment centres are not really technically new. What is new is that they are highly standardised. Their commissioning time is significantly reduced, and they are very flexible. Today, such micro-fulfillment centres mostly use shuttle storage.
Very exciting and current topic. Which sensors are specifically designed to support the implementation of these concepts?
Micro-fulfillment centres are typically standardised, medium-sized distribution centres with around 30,000 to 40,000 storage locations, built using shuttle technology. Through customer-specific customization of the sensors before installation, such as presetting the required sensor functions, specific cable lengths or connectors, they can be installed quickly and error-free in the system or the shuttle.
It can also be seen with sensors that the devices are continually becoming more powerful and efficient. Can you illustrate this trend with a specific sensor and its performance development?
There are many examples, but I'd like to highlight one where it becomes most apparent. If we look at data transmission systems on a stacker crane, the development starts with the DDLS-78, which had a maximum data transfer rate of 9.6 kilobits per second. Its successor, the DDLS-170, had a maximum of 500 kilobits per second and could transmit the first field buses like Profibus or Interbus. The next step with the DDLS-200 was the first optical data transmission with 2 megabits per second that could not only transmit the field buses with serial interfaces, but also Ethernet, TCP/IP and UDP. The latest device, the DDLS-500, transmits at a maximum of 100 megabits and can thus handle all common Ethernet-based field buses in the industry in real time. Due to the increasing data volume, optical data transmission also had to adapt from 9,600 bits per second to 100 megabits per second.
You say that our sensors can check themselves to minimize or even eliminate downtime in intralogistics. But how does that work?
Take the data transmission system mentioned earlier, for example. It consists of a transmitting and a receiving unit. Internally, the device knows the minimum light energy it must receive to safely process the received data. Technically, we set a so-called warning threshold slightly above that value. When this warning threshold is reached, the device provides information through a warning output or the interface to the control system. This can signal that special attention is needed for this sensor during the next maintenance period. Most frequently, this is due to dirt buildup on the optics.
And which of our new products were also developed with this efficiency in mind?
One of our highlight products this year is the new laser positioning system, the AMS100i. This device is used for positioning linear movements such as stacker cranes or transfer cars. This positioning sensor requires very little installation space, can be easily integrated into the application through its modular mounting concept. Its excellent price-performance ratio makes it a possible solution for applications where a laser measuring system was not previously considered, such as applications where a draw-wire encoder would normally be used. Due to its small laser spot, it is easy to align and only requires a very small reflector.
Thank you for your time. If you want more information about our sensors, visit our website at loitze.com.